All right, ladies and gentlemen, please welcome back onto the podcast for his second appearance, Richard Winter. He is the CEO and principal consultant for WinterCorp, and of course, a teacher for us at TDWI. He's going to be teaching a brand new master class, brand new for this year, on on modern data platforms for advanced analytics, artificial intelligence, and machine learning, which is going to be the topic of our conversation today. But before we jump into all that, Richard, thank you so much for your time again. It's great to talk with you. How are you doing today?
Fine, thank you. Thanks for having me. It's a pleasure to be here.
Yeah, likewise. It's we had a great conversation for those that are interested in learning more about the previous conversation that we had with Richard. It's in our catalogs. I encourage you to go back and take a look at and listen to our previous episode together, which is about, modern data architectures as well. But I'm very interested to learn more about exactly how this is going to work. I think it's going to be a great topic for our audience. But before I jump into those questions, Richard, would you mind sharing a little bit of a background? I know we had you on before, but we've gained quite a few listeners since then. So I'd love for people to get a little familiar with you, if that's okay.
Sure. I'm an independent consultant, and I've been focusing in the same area, very specialized area, for now about 30 years. I started my consulting firm in 1992, and my area of focus is the data platform. These platforms of hardware and software that customers use for data warehousing, for query and analytics, for building lake houses or data lakes, that entire family. And I've devoted my career really to studying, understanding, testing, analyzing, evaluating, and helping customers use those platforms. And the particular focus I've chosen is the large scale, unusual or demanding requirements. So the situation where the customer is making a substantial investment to build a database on top of such a platform, perhaps build applications. And there's a significant risk that something would go wrong in the area of performance or service levels or cost, and that would put the investment at risk. So in that situation, I bring special skills and focus and depth of knowledge to the situation, and the customer has something to gain by getting expert help.
Well, and obviously it's no surprise that we're going to be, moving into this new realm of data platforms, and I'm excited to talk with you about this as we head into this, AI realm, and that
Yeah,
seems to be exploding all over the place. So the new class, as I've discussed, is on machine learning, AI, and the data platform. So I'd like to start off by asking, maybe can you just share a little bit of your thoughts on what the data platform is in context to artificial intelligence and the connections between those two?
that's a fascinating question. And most people don't think of these data platforms that way. We think of them as being for business intelligence, reporting, dashboards, the traditional meaning of data warehousing. But what started happening about 15 years ago is that some of the vendors began building in function so that machine learning and certain advanced analytics could be done inside the data platform rather than outside where it's traditionally been done. And then lately, a lot more vendors are doing that, building in the machine learning capability. And also, they're building in capability for generative AI, which I can explain as we progress in the conversation. But with all of these things, with certain advanced analytics, with the things that data scientists do, data scientists have traditionally done these things on special data science workbenches or environments. They do them on Spark, or they do them on in AWS on SageMaker, or on SaaS, or all kinds of products are out there to make it easier for data scientists to do their work in all these areas. But what's happened is that data volumes have grown so large, and also the scale on which some of these technologies is used has grown so large in other dimensions that it's become critically important for some customers to move that processing closer to the data. By moving it closer to the data, it becomes more efficient. It becomes, and there are other advantages that we'll talk about as we go along, more efficient, more scalable. In fact, for some customers, the only practical way to get their workloads done in a timely way in machine learning, AI, and advanced analytics is to do them inside the database. It may not seem obvious to many of them why they would want to work inside the data platform. But the number one reason is this scalability and efficiency reason that I just mentioned. It turns out that there can be other advantages to doing a portion of their work in the production data warehouse platform as opposed to in a separate environment. And I'll just mention one of those now, that in the traditional sort of artisanal approach to data science, take machine learning, classic machine learning. The model is developed in a data science environment, but when it's actually used in production, say to score customers to see what to recommend to them, for example, that scoring is done in a production environment against production data. And the model actually has to be moved from the outboard environment to the production environment. And that's often quite a long process. On the average, research shows it takes 5 months to
Wow.
move in a substantial enterprise to move a significantly important model from pilot to production. If you do the training in the production environment, that movement is much faster and easier and lower cost and less subject to error. So the data scientist's work process can be significantly shortened by compressing that one step.
Well, that's very interesting. I'm curious, what about existing machine learning models that have been created outside of the data platform? Is there a way to fit those in?
There is with some of the data platforms. Some of them offer a feature that's called bring your own model, where the model is developed elsewhere, and there are languages for exporting models. One of them is called PMML, and there are several others. And so if one of these widely supported languages, if the model is, say, developed in SageMaker and then exported using PMML or another supported language, it can be imported into the data platform and then run there, near the data. So that there's an answer to that. So that's important actually, because not only are there many existing data models, but for some problems, they may be very close to an existing model, and the data scientist has a really strong reason for wanting to work in some other environment. And if they do that through the development of the model, then they can still transfer later steps to the production platform relatively efficiently, if it supports that bring your own model idea. So, some do, some don't.
So yeah, I guess my question is, like, have you noticed an advantage one way or the other? I'm assuming it makes more sense to, have it all in-house as opposed to importing one that was created outside, but it also may be a case by case basis. I'm just
It
curious
is,
if
I
you've seen
think
those
it
things.
is a case by case thing. For some, so at this point, we're talking about machine learning. We haven't gotten to generative AI yet, but for machine learning, um, some of the platforms have specific machine learning functions that are built into the platform. And so in that case, it might be relatively easy to create the model in the data warehouse platform, just leveraging these pre-existing functions. In other cases, maybe the machine learning logic is something unique, and the data scientist has to develop a wholly new model for that purpose. That it's probably not going to be practical to create inside the data warehouse platform. You'd create it in your data science environment.
Got it. Okay, that makes some sense. Well, I do want to get into the generative AI side of things. Our audience is always clamoring
Yeah.
for new information on generative AI. So, what is the connection between generative AI and the data platform? Isn't generative AI all about large language models like ChatGPT?
Yeah, well, it is ChatGPT and chat bots in general are a very important part of the picture for mostly for consumer oriented uses of generative AI. But in the enterprise setting, for applications inside the enterprise and for business to business applications, there are a lot that involve the use of enterprise data. So you're asking a question of a Gen AI, uh, but it answers it not just by using its large language model, which has been trained on say the open internet, but by retrieving data from the enterprise data warehouse. Um, and so there are many examples of this, but I mean, one I've heard about lately is answering questions about in an insurance company about prior insurance claims. So a claim comes in, and an examiner, one of the first things they want to know is what's the history of claims from the people mentioned in this claim. If it's an auto accident, there might be several people involved. And one reason for looking at this is that there are fraud conspiracies where the same individuals cause a number of accidents in order to fraudulently or
Hmm.
either cause real accidents or fake accidents in an effort to collect on fraudulent insurance claims. So one of the steps in examining a claim is to look up the history of each person mentioned in the claim and maybe each vehicle used in the claim. So that's a question which you could answer by conventional uh, database query, but you could also have a Gen AI generate the queries, and then the queries would be answered by retrieving data from the database. So that's one connection. Another connection is that uh, generative AI, uh, many of the use cases involve similarity search. So rather than searching by the exact match um, on certain values, the way most database queries are stated, this is the thing is the idea is a person wants to know about the things that are similar to something, or is asking a question about a broad subject in which to get the answer, you want to get all the records that are broadly related to a certain question. That similarity search is done on large amounts of data using vector indexes. And the popular data warehouse platforms all either now have vector indexing or they are adding it and they've announced it. And so there's two capabilities there. There are three: the ability to create the vectors, which is called vector embedding, the ability to store the vectors, and then the ability to search using the vectors. And so all those are being built into data platforms. And, if that's all you had to know as a designer, then we wouldn't need a course. But as usual, there are differences between the data platforms become profound as the requirements become more challenging. So if you have, a relatively small database and kind of very routine requirements that are the same as a million other companies have, then probably any popular platform will be able to satisfy your requirements. But if you have a large data warehouse or your requirements are in some way demanding or more complex than the typical user, if you're in that 5% of companies that have very demanding requirements, then it's very important to you how platform A differs from platform B, not only for business intelligence, but for machine learning, for generative AI, and these other subjects.
Yeah, no, that makes a lot of sense to me. I'm curious, because there's been a lot of, I would say in the last year or so, a lot of news around people that are working within a private environment that have accidentally put their information onto a public platform like
Oh, yeah.
ChatGPT. So I'm curious because the assumption is that sometime down the road, every major organization that has these specific, probably the top 5%, may have their own generative AI, ChatGPT like model within their own business. Is that already happening? Are you seeing vendors that are already offering that kind of solution, or at least starting to get there?
Yeah, that is one of the trends developing. And so there are a few different things going on. One is, so something like Chat GPT and the equivalents offered by other vendors um, is a very large language model. It's truly enormous.
Hmm.
It's got, I believe, trillions of documents ingested. And most companies could not afford to create
Right.
their own version of such a thing. What they're doing instead is taking smaller language models, that have, say, a few billion documents ingested, and then training them on their private data, making a private copy,
Hmm.
training them on their private data. And in that situation, there's no connection with, the outside, the open models.
Hmm.
And so that if that, as long as that architecture is set up correctly, there's no threat that their data will end up on the open internet through operating such a model. Another scenario is using a model, an open model like ChatGPT, but using it to sort of enriching the kinds of answers it can give by having it generate queries against private data.
Hmm.
And this is called retrieval augmented generation. So you ask a question, the language model uses its big language model to understand your question. It generates a query against corporate data to get the specific information, gets the answer and delivers it. And then this has to be done in a way in which the private information is protected and not incorporated into the general model. And that's an area I haven't been involved in deeply so far. I've mainly been involved in what's going on at the database, but uh, I understand that that can be done as well.
Yeah, that's great. I mean, it seemed like there was a bit of chaos there for a little while about people accidentally using, those open source platforms and making mistakes and letting private data be out in the public. So I'm glad there's solutions that are being built and offered to help reduce that issue.
Yeah.
Richard, I got the one last question before I let you go here. I want to see if there, without stepping on the toes of the course, I know we touched on a lot of the material that will be covered. Is there anything else that you wanted to mention specific to this course? Any sort of prerequisites or audience type that you're looking for in attendance here?
So I'm anticipating a sort of intermediate audience, and I don't think any advanced knowledge is a prerequisite to this, but I do think that people need to understand the basic ideas of data warehousing, um, and have some basic knowledge about what a data warehouse platform does when it's used for the things we're used to using them for. Um, and one way to get that would be to take our other course, which I teach with Norbert Kramer. And that's a course on modern data warehouse platforms in the cloud. That would give you the basics of using and selecting a data warehouse platform. But as long as you know the basic concepts, I think you do fine in the course. Um, and then, uh, the reason for taking the course would be to understand how uh, in these, so generative AI is brand new to most of us. Machine learning has been around, but many people still have only a slight exposure to it. And I think it's taking on a renewed importance with the interest in using, it's a form of AI. And companies, I mean, what executives want is for their company to be competitive in the use of artificial intelligence. I think many of the initiatives that will be undertaken will involve generative AI, but will also involve machine learning. And so understanding how these things relate to the data platform, and particularly understanding how they relate to uh, efficiency, cost, this may be a make or break issue in many companies, whether they can afford to field the AI they'd like to be able to use. And the difference between doing some of these things inside and outside the database can be a factor of 100 to 1
Wow.
in cost and performance. And we see examples where it's factors of 100, 200, 300 times more efficient by moving it inside the database. That's going to be a critical success factor. We also see examples where the training that you need to train models, some cases you need to train models offline the night before, and then they're used during the day to make recommendations or detect fraud or whatever it is that they do. And we see cases where you can't train the model overnight because there's too much work to do unless you do it inside the database. And then it happens 100 times faster. Um, we see examples where the only way that the company can make sufficiently rapid progress in its initiative is by streamlining the process of developing and deploying new models. And the key to this is to move some of the work inside the database. Something we didn't get a chance to talk about yet, but is in the course, is the idea of having a shared feature store, which reduces the work for data scientists from one modeling project to the next. If you put that in the database, It's shared, not only is it shared more widely, it's shared more efficiently. The models are more consistent. And then finally, moving the stuff inside the database eliminates a security risk. So lots of reasons to think about taking advantage of this as you develop your AI architecture and strategy in your company.
Richard, thank you so much for shedding some light on this topic. I think everyone that's going to be in attendance in Chicago is going to learn a lot, but really appreciate your time. Always great to talk with you. Thanks again.
Thank you.
To subscribe to the Speaking of Data podcast, or to learn more about TDWI's research and training on all things data management and analytics, visit tdwi.org or click the link in the description below. Thanks for tuning in.